Okay, so this is cannot make it in a full screen. So I hope that you can still see this the letter in this slide. I already uploaded this slide several days ago in our e system. So please feel free to download it. And uh, actually, by this time, I wish you already review some part of review this selection note. And here I just need to uh, add a few information. I mean, detail it out and explain to you uh, some important point, highlight some important point that may benefit for all of us throughout this discussion. So, okay, so our topic is general wastewater collection and treatment design consideration. So, I didn't jump to the topic of design of the sanitary sewer directly because I feel like in order to understand the design, at least we should have some consideration on some parameter or some part of this wastewater treatment system. So the most, so this is the to me this is important because this is how we collect all the parameter which is necessary to identify the most critical parameter, which is like the treatment capacity, the wastewater capacity. So as I mentioned earlier, wastewater the treatment capacity is important because from treatment capacity we can uh, we can estimate the sugar dimension. At the same time, the treatment plant site. Okay, so these are the contents of our discussion today. So we are going to uh, cover several topics. For example, wastewater source and flow rate, where the water come from, wastewater come from, and how do we estimate the flow rate, and wastewater characteristic. So wastewater characteristic. Uh, Actually, this one is just a review because this topic has been covered by Dr. Leonard. Uh, and also you already did several lab regarding wastewater, so this is we don't need to detail out. And wastewater treatment standard, so this also will be a review for you because Dr. Leonard already covered this topic. Sludge disposal regulation, the same. This is just a review because this is have been covered by the previous session. And number five is the plan sizing and layout. So this is we are going to discuss how we lay out our treatment plan, how we lay out the treatment plan, and then how we consider the size of the plant. And last but not least is the plant location. So what other parameters should be considered to locate the treatment plant? Okay, so first of all is wastewater source and flow rate. I'm going to cover this topic. So as you know, wastewater uh, to begin our design of wastewater facility, you know the to to begin the design of wastewater facility, design capacity. That's what I review. I mean, I told you just a moment ago. It's design capacity. So determination of this design capacities is very important, and this design capacity is a function of the wastewater flow rate. So actually, if it's simple word is the design capacity is a cubic. You know, it's it's a uh, it's a cubic it's a cubic meter uh, within uh, how many day, how many time concentration that you allow for the wastewater. It's like your target time in order to treat the wastewater. So this is the design capacity, and it's a function of the wastewater flow rate, which is this wastewater flow rate consists of five parts. For example, selection of design period, estimation of the population and commercial and industrial growth. So this is like projection. Selection of design period. So uh, selection of design period is like how long you would like your your plan last. For example, like 50 year, 20 year, 50 year, etc. So they have some standard for this. It depends on the system that we select. So that's why select a design period mean we select what kind of system that we would like to have it. And number two is estimation of population and commercial and industrial growth. So this is very important because uh, we, when the plan is constructed, this is very. It's not that easy to expand or uh, expand the existing plan based on the future demand. So that's why we have the future demand based on the target, for example, like 20 year or 50 year target. So we plan based on that. So number three is estimation of wastewater flow. So after we calculate the population growth, commercial and industrial growth. So now we can estimate the wastewater flow based on the formula. And number four, estimation of filtration and inflow. So this is another parameter that is important for the design for estimating the wastewater flow. Because infiltration and inflow is related to the additional amount of water that is coming from the groundwater, like infiltration, is coming from the seepage water. Could be through the manhole, could be through the crack along the pipe, and also the inflow is like additional surface runoff that is coming in through the system, especially like a manhole. And number five is the estimation of variability of the wastewater flow rate. So we can uh, we can estimate the wastewater flow rate uh, based on the uh, variable, several variable parameter. So will be detailed out in the topic. Okay, so they have okay. First of all, is selection of design period. So you can see here, design period is based on the following criteria. So if we consider about design period, we consider on this several parameter. For example, regulation constraint, rate of population growth, interest rate of for bonds, if we borrow the money from other agency, the useful life of the structure and equipment, the ease or difficulty or expansion, performance in early year of under minimum hydraulic load, etc. So, uh, so these are the criteria that we have to consider when we select the design period. So they have some standard from in US. The design period is we you can see that the type of facility. See that we have the type of facility. We have type of facility is a fixed facility. For example, characteristic is difficult and expensive to enlarge and replace. Okay, so design period is around 20 to 25 year, and equipment is easy to refurbish or replace. So you can design period if you have the equipment, a treatment plant that use the equipment, and this equipment is easy to refurbish or replace. So maybe design period is around like uh, 10 to 15 years. But if you choose like fixed facility, I mean difficult and expensive to enlarge or replace, so design period could be reached until like 20 to 25 a year. And then the system, like for this topic, we are talking about the collection system. So this is a trunk line and interceptor, which is greater than 60 centimeter. So replacement is expensive and difficult. So we can design period could be allocated around 20 to 25 years. And if the lateral and main collecting system, which is less than 30 centimeter, so this is easy to refurbish or replace. So this is a full develop. Okay, so uh, so this is a full develop. So all right. Okay, so now we move to the next topic, which is about the estimation of population and commercial and industrial growth. So this is the when you talk about the population and commercial industrial growth, you are talking about the component of wastewater or source of wastewater. So the wastewater, so in order to estimate those growth, so we need to think about the source of those wastewater. So wastewater can be from domestic or sanitary wastewater. So okay, make it easy. The source of wastewater, it can be from like four sources. It could be from domestic or sanitary wastewater. It can be from industrial wastewater, or it can be from infiltration and inflow, and from the storm water. Okay, storm water. So let us go So where the water from domestic or sanitary sewer water? They are from residence, commercial, for example, bank, restaurant, retail store, university, institutional facility like a school and hospital, etc. So these are the domestic sanitary, domestic wastewater. And from the Malaysian standard, so usually you will the Malaysian standard allowed like 235 liter per capita per day, and we have industrial wastewater. So industrial wastewater, it could be from usually it's from industry. So for example, manufacturing and chemical processes. So from the Malaysian standard, it say that 20 cubic meter per hectare per day. It will be allocated for light industry. So if light industry is 20 cubic meter per hectare per day, but if more than if the industrial type is not considered as light industry, so we have to go to we have to calculate it based on the population equivalent, which is the next slide. Okay, and then the next one is infiltration and flow. So usually the abbreviation term is I slash II. So this II refers to infiltration and flow. So they are from, where are they from? Where are the water from? Where are where, what are the components that is considered as II? They are from groundwater infiltration and storm water from roof drain, the water from foundation drain, and the water from submerged manhole. So usually in Malaysians and that consider allocate around 50 liter per millimeter of pipe diameter per kilometer per day. So this is the amount of water, I mean the wastewater, that is considered in infiltration and flow. And for the Hammond stormwater, so stormwater, it is from a runoff of rainfall and snowmelt, but usually it is excluded. In nowadays, this we call it combined system. The combined system is not popular anymore. Like especially in Malaysia, Malaysia doesn't use the combined system, meaning that you combine the sewer water with the wastewater, which is the design capacity will be very great, especially it will be involved with the rainfall so much actually. So that's why it is not included in the component of wastewater. Okay, so now we go to the core, how to estimate the wastewater flow. Okay, so the wastewater. Okay, this is the wastewater peak flow. So to calculate the wastewater peak flow, we use the Malaysian standard MS 1228. So it states that QW, mean this is QW is the wastewater flow rate. QW is equal to K multiplied with 0.225 multiplied with PE multiplied with P divided by 1000 exponential minus 0.11. So this is the equation that we can apply to calculate the wastewater flow rate. Okay, wastewater flow rate. Which is P is a population equivalent. I have the standard. I have the standard value from IWK in the next slide. And then in order to, but this is not the end. The peak flow for the wastewater. So the peak flow for the wastewater should be calculated by including the II, infiltration and inflow. So that's why QPF means peak flow. The Q peak flow of wastewater is equal to II plus the QW. So as you know, the infiltration and inflow is around 20 liter per millimeter of millimeter diameter of the pipe per kilometer per day. So just follow it. So you have to estimate how many kilometer of your pipe, and then you multiply, you will get the amount of II. So this is the wastewater peak flow. I mean, this is the population equivalent. Remember, population equivalent. So, for example, let's say residential area. This is a residential area, so you will have, let's say in your land use, you have a plan land use, So you estimate how many houses are in a residential area. So one in residential area, population equivalent is 5 per house. Okay, so this is 5 per house. Once again, population equivalent is not referred to the population. So this is the amount of this is the unit that is used for estimating the wastewater. So uh, in order to get the actual population, you may have the conversion factor from a Malaysian standard, and for okay, back to our standard. So for residential, 5 per house. Commercial, you see that 3 per square 100 square meter per gross area. And school, that's the school. Okay, and we will have around day school institution, 0.2 per student. A fully residential school, so it will be 1 per student. Partial residential is 0.2, etc. Okay, and then we have hospital, 4 PA per bed. Hotel with dining and laundry facility is 4 per room. And then this is a wet market. We have wet market and dry market. So wet market we have 3 per stall, and dry market we have 1 per stall. Okay, and then we have this is another one. We have a petrol station. We have petrol station with around 15 PE per toilet. And then we have a bus terminal, 4 PE per bus bay. And we have taxi terminal, is 4 per taxi bay. Masjid, church and temple, we have maybe 0.2 per person. Stadium, swimming pool and sport complex, public toilet, airport, laundry, prison, go-kart, etc. Okay, so these are the standard, and then remember the factory, industry. So this is the industry. So if the industry is not considered as a light industry, so we can use this standard. Okay, we can use this standard. All right, let us move on. After we estimate the wastewater flow, so now we let us see a little bit detail about the infiltration and inflow II. So infiltration and inflow, they are different actually. If you want to go into detail, so this is the definition, and the next slide will show us about the how to detail estimated the how to the estimate how to estimate those parameters in detail. So infiltration is water entering the sewer system. So it could be uh, include the sewer service connection and from the ground through foundation drain, defective pipe like crack, like joint, pipe joint, connection, and manhole wall. So these are the component for the infiltration. For the inflow is water discharge into the sewer system, into the sewer system, including service connection, source from such source from the source, for example, roof, downspout, basement, yard, and area drain, cooling water discharge, drain from spring and swamping area, manhole cover, uh, from storm sewer and combined sewer, catch, catch basin, catchment basin, stormwater, surface runoff, street water or drainage. So these are uh, the source of the infiltration and inflow. But in Malaysian standard, you don't need to detail out like that. Just take the Malaysian standard, consider 50 liter per millimeter diameter per kilometer of the length per kilometer pipe length per day. Okay, estimation of the variability of the wastewater flow rate. So, okay, so for the variability of wastewater flow rate, we can see that uh, we have different d- we have the different flow rate. Okay, we have different flow rate. For example, let's say average daily, minimum hour, minimum day, minimum month, peak hour, maximum day, and maximum month. So these are the variability of the flow rate, and this variability of the flow rate is very important because they are they are going to be used for different purpose. For example, every daily, this is based on the development of flow rate ratio for estimating the pumping, sludge quantity, and chemical dose identification of sugar where flow will not achieve a minimum velocity. So we use this average daily uh, to estimate or to operate all of these condition, and then we have a max minimum hour. This is this variability, we use it in order to estimate turn down ratio turn down ratio of pumping facility and low rain for plant flow method. Okay? Estimated turn down ratio for pumping facility and low rain of plant flow metering. So meaning that the pumping facility, the amount of flow rate, the minimum amount of flow rate, it should be not less than the amount of flow rate, amount of minimum per hour of flow rate. And then we have minimum day. So this is sizing of plant component, influent channel, biological treatment system, including recycled equipment, a requirement for treating filter. So, for example, this is another parameter, minimum day. So minimum day, we use it for the sizing to calculate the dimension of the plant component, especially like effluent channel, biological treatment system, etc. And then we have a minimum man. Minimum man is a selection of minimum operating unit required during the low flow period. Minimum operating unit required during the low flow period. Okay, so this is for the operation. So this amount is this is the component that this is the parameter that we selected in order to operate the this is the like minimum flow rate for the operation during the low flow period. So it's included it including the shutdown of the maintenance of like very low flow, we can shut down for maintenance, etc. So peak hour, how about peak hour? This is a sizing or sanitary sewer. So this is important for you have to remember this. Our topic is about this part. Sizing of the sanitary sewer, sizing of pumping facility and the channel, sizing of physical unit operation including bar, rack, and screen, grill, grid chamber, etc. So this have to be the peak hour. So we use peak hour to calculate to determine all those dimension of this component. Maximum day. How about the maximum day? Sizing. We use it in order to sizing equalization basin and sludge pumping system. Okay. So to calculate the equalization basin and sludge pumping system, we use the maximum day. Maximum month, this is a sizing channel, chemical storage facility. So to calculate the how much the chemical should be stored in the storage house, we have to use the maximum month of the flow rate. All right, so this is the variability of wastewater flow rate. Okay, so sometimes we have a difficulty to estimate all those parameters. So this in we can you can see here uh, this is alternative method of estimating the variability. So sometimes we find it difficult to collect all those data. So it doesn't matter if we have like only one parameter, for example, everyday daily flow. I'm sure average daily flow is it's easy to get it because uh, we can estimate it or can measure it if you would like to upgrade the existing existing system. So average daily flow we can estimate, and then we can use this with this graph. With this graph, so this graph is pre-built. Okay, so if the agency, for example, let's say municipality of the town, municipality of the town have this data, we can use this directly. Otherwise, we can use from literature reviews, for example, like this. So this is the you can see this is maximum day. This is the maximum day. This is the peak hour on maximum day. This is the minimum day. This is the minimum day of minute per day. So this one is the peak hour. Peak hour. Okay. For example, we have daily flow rate. For example, let's say 1000. So now you go to here, you can see that this is the minimum hour or minimum minutes per day, and you hit this one will be the minimum day, and you hit this one and the maximum day, or you hit this one will be the peak hour on maximum day, etc. Can estimate from this. Uh, Another one is this is for the flow rate, and then this is the method of estimating peak infiltration flow. Okay, you remember I and I, so this one. So you can estimate I and I based on this monograph. Okay, so this is it depend on this one. It depend on the service area. You can see that it depend on the service area. So for example, let's say if our service area is 100, let's say 100 hectare. So this is 100 hectare. So this one for this curve. This is for the curve. This new server. So if you would like to have you install a new server, perhaps you need to have this one. So if you have 100 hectare, but you are constructing the system based on the old server. So this is so you hit this graph, and then you come here. So this is the peak infiltration rate, cubic meter per hectare per day. All right, so okay, so we stop for a while, and then we continue for the wastewater characteristic.